Some may look at this and say that I have an unhealthy obsession with enterprise graphics cards. This isn't even half of my collection. Today's video is brought to you by Maximum Settings Cloud Gaming. This is a gaming PC, but it's not exactly portable. This is also a gaming PC, but it's not exactly powerful. What if you could turn any device you already own into a PC as powerful as this, while being as portable as this? With Maximum Settings Cloud Gaming, you get access to a powerful gaming PC in the cloud from basically any device you already own. For example, here's Helldivers 2 running on an Ein Odin Lite Android handheld. Here's Cyberpunk 2077 running on my phone. Virtualized gaming machines start at just $9.95 Canadian, or around $7.40 US, and you'll be up and gaming just a few minutes after creating your account. Or for uncompromised performance, opt for bare metal access with an AMD 7800X 3D CPU and a Radeon RX 7900 XT graphics card. Get the flexibility of a cloud gaming system without the hassle of building and maintaining one yourself. Visit MaximumSettings.com or visit the link down in the video description to get started today. And again, thanks to Maximum Settings Cloud Gaming for sponsoring today's video. Welcome back to Craft Computing, everyone. As always, I'm Jeff. I started investigating the idea of self-hosted cloud gaming servers on this channel almost exactly 5 years ago. This journey has been one of the most fun, the most exciting, the most viewed, and the most expensive project ideas I've ever had on this channel. And that's saying something from someone who has a lot of expensive ideas. The concept was pretty straightforward, I thought. Use a single graphics card to virtualize multiple desktop systems at once with full GPU acceleration enabled. This would allow me to host a single server in my rack and enable multiple users to access full desktop systems for 1080p gaming, video editing, or any other desktop task. And this could all be done from a simple thin client device, like a Raspberry Pi, a Chromebook, or even from your phone or tablet. The primary method I've been using to do this is Nvidia's Grid system, a proprietary driver set that allows splitting a single Nvidia GPU into multiple virtual GPUs for use in virtualization environments. It allows graphics cards to split up GPU memory and then dynamically allocate graphics power where it's needed. But there's a catch. Nvidia Grid is only enabled with certain models of Nvidia Tesla GPUs, typically only the ones that cost north of $5,000 each, so it was never a technology that was intended for us mere mortals. To say I'm passionate about this product, I think would be quite the understatement. I shuddered to think just how much money I've spent over the last years trying to get this project to fruition. Sure, the project started humbly enough with a Dell R7610 rack mount server, along with 3 Nvidia Tesla K10 GPUs that I picked up for about $40 each. What's funny is the Tesla K10 isn't even a supported GPU when it comes to Nvidia's Grid. I had to physically modify the card by swapping resistors on the PCB and then forcing a BIOS swap to get the card to think it was actually an Nvidia Grid K2. Even once that was up and running, it could barely play Doom at 60 frames per second, with some pretty serious stuttering. Then, I kind of went off the deep end and bought an AMD EPYC 7601 32-core processor, and a fan happened to donate a pair of Tesla M60 GPUs. Now, while the project worked, it never met my expectations for running well. Kepler and Maxwell GPUs just didn't have enough horsepower, even back in 2020 when I was testing these, to properly run multiple games at 1080p and 60 frames per second. And then, a breakthrough, whether spurred on by their own masochism or possibly by my own foray into the subject, the community came together and managed to unlock grid functionality on any Nvidia GPU from the Maxwell, Pascal, and Turing series of graphics cards. This was a massive game changer, as now instead of buying cards like the Tesla P40, which were well north of $3,000 at the time, we could essentially unlock a GTX 1080 Ti and get the same capability out of that. That experimentation took me down an even deeper rabbit hole, culminating in a 64-core EPYC Rome 7742-based server, along with 3 Titan X Pascal GPUs. The system was able to virtualize a full 12 gaming machines, splitting the GPUs into 3GB chunks, essentially netting me the performance in line with a GTX 1060 3GB. Plenty for 1080p gaming at the time. But like every enthusiast who just doesn't know when to quit, I wanted more. But there was also a problem. Remember, the grid unlock method only works for GPUs from Maxwell, Pascal, and Turing architectures, which means the best possible card you could get would be either a 2080 Ti or an RTX Titan. And RTX Titans to this day still sell for north of $800 on the used market. There's no real way to unlock grid functionality on Ampere-based GPUs. So, what's a virtualization enthusiast to do? Well, I figured it was finally time for me to join the ranks of the officially supported. Meet the Nvidia RTX A5000, an Ampere-powered graphics card that shares the same GPU die as the RTX 3080, albeit a slightly cut-down version. What we're looking at is 8,192 CUDA cores instead of the 8,704 on the RTX 3080. But what makes the A5000 special is its 24 gigabytes of GDDR6 memory. One of the struggles when it comes to splitting up a GPU for virtualization is you divide them based on the memory. When I split a GTX 1070 Ti, for example, a 4-way split means each virtual machine gets just 2 gigabytes of video memory. Not exactly a great number in 2024, when 6 to 8 gigabytes is required for a good number of titles at 1080p. With 24 gigabytes to work with, that means I can easily allocate 6, 8, or even 12 gigabytes of video memory to multiple virtual machines, depending on what my goals are. Now, I've been teasing these GPUs for over a year now, but the reason you're only just seeing them now is I was never quite happy with their performance on the systems I was running. I've tested these on both Intel Xeon Broadwell and my AMD EPYC Rome 7742, and both of those felt like they were really holding the A5000s back. But now, thanks to AMD, I've got access to the EPYC Genoa 9554, a 64-core Zen 4 CPU. Yes, it is a server processor, but you'd never guess that by looking at the specs. It still manages a base clock of 3.1 GHz with a boost speed of 3.8. Still a bit pedestrian by modern standards, sure, until you consider that all 64 cores are able to hit those speeds at the same time. For testing today, we're firing up 4 virtual machines running in Proxmox, each configured with 12 threads and 24 gigabytes of memory. Now, keep in mind, in virtualized instances, a thread isn't necessarily a hyper-threaded pair. If Proxmox has enough free physical cores, it can allocate all 12 of those virtual threads as real cores, essentially boosting what would normally be a 6-core 12-thread performance by as much as 60%. So what kind of uplift in CPU performance are we talking about? Well, my most recent cloud gaming server is an Asus ESC4000 G3, loaded up with a pair of Xeon E5 2697V4 18-core CPUs. These may turbo on paper to 3.6 GHz, but they have a base clock of just 2.3. And when most cores are being utilized, like in gaming workloads, and you have every single thread on the server utilized to VMs, the CPU can barely hold on to 2.6. That 18-core chip by itself has a Cinebench R15 multi-threaded score of 2504. Pretty respectable, right? Well, running just 12 threads in a virtual machine of the EPYC 9554, we managed a score of 2405, just 100 points shy of that entire 36-thread CPU that I'd been using to power my cloud gaming server. Sure, the ESC4000 has dual CPUs for a total of 72 threads, but the 9554 has 128 threads to work with. So, CPU bottleneck solved. As far as the consumer equivalent CPU to what we're running in the VM, we're looking at a single and multi-threaded performance on par with the Ryzen 3800X, which has been more than enough performance for modern-day 1080p gaming. And one last bit of housekeeping on the server, one of the most difficult aspects of these VDI machines that goes unnoticed is storage. While NVMe drives are incredibly fast, they're not often designed to handle multiple clients running an OS and trying to load game assets all at the same time. Attempting to run even 4 virtual machines off a single NVMe has resulted in multiple minute load times in the past and even some game crashing, something that doesn't fly in real-world use. If you didn't see the build video for this server, we're running 4 Corsair 2TB MP700 Pro Gen 5 NVMe drives. Each of these disks individually can push around 12,000 megabytes per second. Now, in my first test, I opted to go with ZFS RAID Z for pooling all of the drives together. And I saw results of about 21 gigabytes per second total on the array. Of course, there's going to be some losses when running virtualized disks in a VM. And testing a single VM, we see read speeds of just 2,979 megabytes per second, with writes coming in at 2492. But that's for one system. Things get interesting when I tested all 4 VMs simultaneously, as the read speeds actually increased slightly per individual VM up to 3,093 megabytes per second. Writes did slow down pretty significantly to around 700 megabytes per second, but the fun part is random IOPS stayed exactly where they were from the single VM test. If I had to guess, I would say this might have something to do with the virtual disk controller on the VM, because we are still emulating hardware, and hardware has protocol limitations that still need to be followed. It definitely is going to take some more testing to suss all this out, but right now, the results are more than good enough for what I'm trying to do here. So, with all that out of the way, let's finally get into the GPUs. If you've watched some of my most recent vGPU test videos, I'm using the same methodology here. I'll be running a single virtual machine to test max performance, and then running 2 virtual machines off of a single card, with VM number 2 running GTA 5. Where we ran GTA 5 at high settings last time, I've turned everything up to max settings today, so testing won't be exactly apples to apples based on previous results. But that's also the point of upgrading to Ampere GPUs, right? I am going to show results from the Tesla P40, but again keep in mind this isn't a direct comparison, as the P40 was running off the Broadwell Xeon and had different settings in games. Starting off with DirectX 11 and 3D Mark Firestrike, the P40 running a single VM managed a graphics score of 21,755, with the second VM dropping that score to around 40% of that at 9,866. And right off the bat, the A5000 absolutely embarrasses my previous high watermark, with a graphics score of 32,281 on a single VM and 17,719 when running a pair of them. That's an improvement of 48% for a single gaming VM and a whopping 80% faster when running 2 VMs off of the same card. The combined score is even more impressive when you take the CPU performance into account, which scores more than double that of the P40. So we're off to a pretty good start so far. Moving on to DirectX 12 and 3D Mark Time Spy, the hits continue as the P40 manages a score of 6,544 in a single VM and 3,942 when running on 2. The A5000 improves on the single VM score by nearly 88% at 12,291, and more than doubles up the multi-VM performance with a score of 8,504. One thing that's apparent even in these first couple tests is performance scaling for multiple VMs is vastly improved on the A5000 over previous generation GPUs. While we are seeing some very impressive performance gains on a single VM, running multiple VMs always came with a penalty on Pascal series chips. On Ampere, rather than seeing a 60% performance hit when running multiple VMs, it's actually less than 50%, meaning that the card is actually more efficient when splitting the load among VMs than when running solo. And that's a very encouraging result as we move into gaming. We'll start off game testing with Tiny Tina's Wonderlands, where the A5000 not only hits 60 frames per second on average, it's good even if you wanted to stream at 144 Hz, with an average of 153 frames per second at a 1% low of 87. Running a second VM with GTA 5, we still get some very impressive performance, with an average of 86 frames per second and a 1% low of 54. Looking over at the P40, it's easy to tell that these gaming benchmarks are going to be nothing short of a bloodbath. At the exact same settings, that is 1080p and high presets, the P40 managed just 81 frames per second on average, but a 1% low of 10. That means the A5000 running Tiny Tina and GTA 5 at the same time is still 6% faster on average than the P40 running Tiny Tina by itself. And that's to say nothing of the low frame rates. The A5000 1% lows for each test were faster than the average results of the P40. And we're just getting warmed up. How about diving into a game that absolutely hates running on the Pascal architecture? Starfield struggles hard in those chips. And at medium settings, the P40 managed just 35 frames per second on average with a 1% low of 14. Firing up a second VM, and the results are even more disappointing, at 19 frames per second on average, but the lows drop all the way down to 11. I also tried enabling FSR3 on the P40 during testing, with little to no effect. The A5000, running at high presets, completely obliterates the P40, where we see a single VM running at 73 frames per second on average, with a 1% low sitting at a very comfortable 49. Running GTA 5 on VM number 2 does see our performance fall, but it still stays well within a playable frame rate, with an average of 43 FPS and the 1% low sitting right at 30. Of course, with modern GPUs comes modern performance uplifts, and the A5000 has access to DLSS. And seeing as how we're already streaming this game session over a network, most of the visual anomalies people love to complain about are likely to be hidden by compression artifacts here anyway. So we might as well take advantage of the extra performance, right? With DLSS Ultra Performance enabled, the average climbs all the way up to 94 frames per second with a 1% low just shy of 60. Running a second VM was equally impressive, with an average of 53 frames per second and a 1% low of 36, making the game more than playable even if you wanted to run multiple copies. On a network stream, there's very little to complain about there. Moving on to Wreckfest, the P40 had one of its best showings of the day. Running at high settings, it managed 154 frames per second on average, with a 1% low of 58. And even when running 2 VMs, the average stayed well above 100, with the 1% low falling to just 39. Well, that's kinda cute. The A5000 running at ultra settings again destroyed the old Pascal card with an average of 215 frames per second, a 1% low of 115, and even a 0.1% low of 101. Running a second VM, we see the average still hit 121 frames per second, and even the 0.1% low stayed well above 60 at 64 frames per second. In every sense of the word, this was impressive, and bodes well if you wanted to further split up the A5000 into even more virtual machine instances. Ooh, foreshadowing. Now, if we're going to be running GTA 5 as the scapegoat on the second VM, it's worth knowing what kind of performance we'll be seeing out of it. At high settings, the P40 managed just 56 frames per second on average, with a 1% low of 23. Now, it should be worth noting, this was also one of the worst CPU bottlenecks I experienced on that Xeon-powered server, as running 2 instances of GTA 5 on the same graphics card resulted in identical performance. When it comes to the A5000 though, a single VM managed 150 frames per second on average with a 1% low of 74, and even a 0.1% low of 46. Running a second copy of GTA 5 didn't slow it down that much either, hitting an average of 137 FPS with nearly identical lows. But I wanted more, and I figured GTA 5 might be the right title to see just how far I could stretch an A5000 and still stay above 60 frames per second. Running 4 VMs, all running GTA 5 at max settings, all on the single RTX A5000, we still managed an average of 70 frames per second and a 1% low of 48. In fact, with the pair of A5000s I have in the server, I could run 8 copies of the game at max settings and host my own 5M dedicated server for multiplayer. It's plausible that I could drop the game to high or even medium settings and split the GPU even further. What about running 6 4GB chunks per card for a total of 12 virtual machines? Heck, I'm betting even 3GB chunks would be able to run this game well enough. Let me know if you want to see a video seeing how far we can push the server, and if running 16 copies of GTA 5 would be a good enough test for that. And last but not least, we come to the Dark Souls of performance testing. By that, I obviously mean Cyberpunk 2077. When testing this on the Tesla P40, I ran the game at medium settings, and even that proved to be a bit too much for the old girl, hitting 54 frames per second on average, but with a 1% low of less than 20. The game was choppy and inconsistent, and that was even before I tried running multiple VMs. Testing at FSR also made little to no difference, with low frame rates barely above single digits. So how will the RTX A5000 fare? Well, the A5000 is still an RTX-capable card, so I figured we'd take full advantage by enabling DLSS, as well as turning on some of the eye candy. Running at RTX low preset, which is essentially ultra settings with ray trace shadows, we get an average of 91 frames per second with a 1% low of 53. As in, the 1% low of the A5000 nearly matches the average frame rate of the P40 running at medium settings. Running GTA 5 on a second VM, performance falls, but manages to stay above 60 frames per second and very playable, with an average of 67 FPS and a low of 44. Of course, what would the worst case scenario be? GTA 5 only uses between 35 and 40% of the GPU power by itself. What if we ran 2 copies of Cyberpunk? How much would the A5000 cry then? As it turns out, this is a very usable configuration, with the game averaging 56 frames per second, a 1% low of 42, and even an impressive 0.1% low of 32. 2 VMs, each running Cyberpunk 2077, and managing almost 60 frames per second. To say I'm floored by the results would be quite the understatement. Ampere was a dramatic leap forward in performance for Nvidia, regardless of how ridiculous pricing for the consumer market wound up being. The enterprise market didn't see quite as dramatic of an increase in price. That wouldn't happen until Hopper was released, making the A5000 and A6000 cards absolute beasts when it came to not only machine learning, but VDI-based workloads as well. This has been an incredibly long and winding road, and I couldn't be happier with the results here. Well, I could. The only problem is solutions like this are still out of reach for anyone running to run this in their home lab, or even as a small business for remote workers. I haven't mentioned it recently, but Nvidia Grid licensing is prohibitively expensive for anyone but those with the deepest of pockets. And that really is a shame, as there's so much potential here for these cards to be used even well after their shelf life in enterprise has expired. Personally, I'm running a Tesla P4 in my main VM host. I've got 2 Windows PCs that I can access with full GPU acceleration for sandbox tests, as well as a third instance of the GPU attached to my Plex server for media transcoding. Rather than needing 3 GPUs, I've just split this now very budget card into 3 different pieces, saving me money on hardware, using less overall power, and not needing as many PCI slots on my server. I would love to see virtualized GPUs get more support. Being able to run a workstation with GPU-accelerated VMs has been a dream of mine for well over 10 years. Allowing a single PC to run any OS that they need at a moment's notice without any compromises in performance and without the hassle of dual booting? Sign me up. Windows Hyper-V does allow similar bifurcation of GPUs, but it is limited to Windows clients due to the handling of drivers on the host. And in a future video, I might give that another look to see just how well it handles consumer GPUs, like the RTX 3090. But for now, I think it's time to wrap this one up. If you're interested in any of the hardware that I mentioned in today's video, I will have affiliate links down in the video description. Make sure to go give those a look. Those are affiliate links, so I do get a small kickback from anything that you buy from those, but that does help keep the lights on around here. On your way down there, make sure to drop this video a like and subscribe to Craft Computing if you haven't done so already. And if you like the content you see on this channel and want to help support me in crazy expensive projects like this, head on over to craftcomputing.store and pick up some of my merch, or join the Patreon and get access to the Discord. But that's going to do for me in this one. Thank you all so much for watching, and as always, I will see you in the next video. Cheers, everyone. Beer for today is from Lassen Aleworks, or Lassen Aleworks, Lassen, out of Susanville, California. This is the Eagle Lake IPA, clocking in at 5.7%. So, Lassen Aleworks, Lassen Aleworks, Lassen, I'm going to say Lassen, not quite sure. It does say it's the law, though. So, Eagle Lake IPA. Super, super bitter. And super, super dry. Boy, if this ain't a West Coast IPA. This description is not going to win a lot of people over. It's like dandelions, lemon, and dirt. And I do not hate it. Yeah, this is one of those unabashedly bitter IPAs. I don't know, man. Drinking this beer, my mustache is getting a little thicker. I feel additional rims being formed around my glasses. My shirt's even slightly more plaid than it used to be. This is definitely not an IPA for everyone. I like this style of IPA. I'd say 20% of people really do, though. If you love that ultimate bitter, dry, not even dank, just vegetal kind of flavor, this one's definitely worth a look. If you're the kind of person who thinks IPAs are a little bit too piney, look elsewhere.